The sun blasts out highest energy radiation ever recorded, raising questions for solar physics. Monisha Raviseta reports, "We thought we had this figured out, the star figured out, but that's not the case." In a record-breaking discovery, scientists detected our very own sun emitting an extraordinary amount of gamma rays, wavelengths of light known to carry the most energy of any other wavelength in the electromagnetic spectrum. And this is quite a big deal, as it marks the highest energy radiation to ever be documented coming from our planet's host star. Something like 1 trillion electron volts to be exact. And after looking at 6 years worth of data, she said, "Out popped this excess of gamma rays." Moore Onisa, postdoctorate research associate at Michigan State University and co-author of the new paper, said about the findings released on Wednesday, August 3rd. "When we first saw it, we were like, we definitely messed this up. The sun cannot be this bright at these energies." What does that mean for us here on Earth, though? That's the question. Upon deliberation, however, the team realized that such brightness definitely existed, and it was simply due to the sheer amount of gamma rays the sun seemed to be spitting out. And Nisa said, "The sun is more surprising than we know. And before you start worrying, no, these rays cannot harm us, but what they can do is have a pretty important ripple effect for the future of solar physics. In fact, they have already raised some important questions about the sun, such as what role its magnetic field might play in the newly observed gamma ray phenomenon. What an excess of solar gamma ray looks like to the high altitude water Cherenkov Observatory collaboration. It's all thanks to a unique lens that the cosmos called the High Altitude Waver Cherenkov Observatory, or HAWC for short. In short, this observatory, completed in the spring of 2015, is a facility specifically designed to observe particles associated with very high energy gamma rays and cosmic rays, the latter of which are equally energetic but also mysterious in that they often travel across the universe without exhibiting a clear starting point. And in this particular energy regime, other ground-based telescopes could not look at the sun because they only work at night, Nisa said. Ours operates 24/7, he said. HAWC basically uses a network of 300 large water tanks, a press release on the new study explains. Each of these tanks is filled with about 200 metric tons of purified water, and they all sit nestled between two dormant volcano peaks in Mexico, more than 13,000 feet above sea level. And all of this purified water is important because as high energy particles from the space strike the liquid, the collision results in a phenomenon known as the Cherenkov radiation, which you may have heard of if you're watching the TV show Chernobyl. Named after 1958 Physics Nobel Prize laureate Pavel Cherenkov, Cherenkov radiation essentially refers to a bluish glow that happens when electrically charged particles move at a certain speed through a certain medium, in this case water. Tapping into this concept, HAWC's overall field of view covers 15% of the sky, allowing it to survey a total 2/3 section every 24-hour period and figure out the routes of various high-energy particles headed to our Earth. A composite image shows a photograph of the high-altitude water Cherenkov Observatory. Now, what's normal solar radiation like? These are questions have to be answered by these cosmologists. The question I have is, what does this higher ever radiation coming from the sun do to us and our weather patterns here on Earth? This is on Out of Mind too. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.